For millennia, humanity has looked up at the night sky and asked a singular, defining question. Are we alone in the cosmos? While early missions proved that planets are a common feature of our galaxy, a new pioneer was launched to map our immediate cosmic neighborhood. This is NASA's Transiting Exoplanet Survey Satellite, or TESS. Led and operated by MIT and managed by NASA's Goddard Space Flight Center, TESS set out with an ambitious goal: to conduct the most comprehensive planet-hunting expedition ever undertaken. It was designed not just to find distant, random worlds, but to discover exoplanets orbiting the brightest, closest stars to our own solar system. These are the worlds that future generations of instruments will study for decades to come, searching for the telltale signs of alien life. How does a satellite, smaller than a subcompact car, discover worlds trillions of miles away? The secret lies in TESS's unique vantage point and unparalleled precision. To conquer such an overwhelming task, the satellite transforms the infinite expanse of the night sky into a highly disciplined grid. TESS utilizes 4 large, advanced cameras to monitor vast strips of the sky, measuring 24 by 96 degrees, known as sectors. Each sector is observed continuously for approximately 27 days at a time. This unwavering, unblinking focus allows the spacecraft to catch the subtlest cosmic fluctuations before moving on to the next patch of the endless dark. TESS hunts for transits. Essentially, it is a microscopic eclipse occurring trillions of miles away. When an orbiting planet crosses directly between its host star and our point of view, it blocks a minuscule fraction of the star's light. This causes a telltale rhythmic dimming. By capturing these subtle dips, TESS can calculate a planet's size, its orbit, and its distance from its sun. Through this extraordinary precision, a mere cosmic shadow is transformed into the undeniable signature of a brand new world. During its primary 2-year mission, which concluded on July 4, 2020, TESS imaged roughly 75% of the starry sky. Spending its first year mapping 13 sectors of the southern hemisphere before turning around to survey the north. The data volume was staggeringly immense. TESS returned over 20 terabytes of southern sky data alone during its initial year, a treasure trove comparable to streaming nearly 6,000 high-definition movies. The sheer scale of TESS's achievements is perfectly captured in its dazzling panoramic mosaics. To build this masterpiece, TESS divided the southern sky into 13 distinct sectors, with its 4 advanced cameras monitoring each zone for nearly a month, searching for the rhythmic dips of distant starlight. While hunting for alien worlds, TESS also became a sentinel for cosmic anomalies, catching transient events like passing comets and violent supernovae. Arcing beautifully across the landscape is the glowing, edge-on view of our home galaxy, the Milky Way. Zooming into the mosaic, the level of stellar detail is staggering. At the very center lies the continuous viewing zone, where the sight lines of TESS's cameras overlap. Nestled within are our cosmic neighbors. The Large Magellanic Cloud, located 163,000 light-years away, the more distant Small Magellanic Cloud, and the brilliant, dense ball of stars known as the globular cluster NGC 104. Silhouetted against the bright band of the Milky Way, TESS captures the Coalsack Nebula, a cosmic cloud of obscuring dust resting in the famous constellation Crux, also known as the Southern Cross. The panorama guides us through iconic stars. We encounter Alpha Centauri, our nearest neighboring system, and Fomalhaut, which famously hosts one of the first directly imaged planets. We pass Sirius, the brightest star in our night sky, and look to Orion's shoulder to find the red supergiant, Betelgeuse, hanging just above the breathtaking Orion Nebula, a vast stellar nursery. Yet, not every spectacular shape is a cosmic mystery. This strange, ghostly glow near Orion's feet is actually an optical artifact, a reflection of the ultra-bright star Rigel, caused by intense starlight scattering off the internal lenses of TESS's own camera system. Scattered across this southern sky are TESS's confirmed planet discoveries, including multi-planet configurations and several Earth-sized worlds. Thousands more candidates await confirmation. Naturally, the sectors studied first show the highest density of discoveries, giving astronomers more time to decode their secrets. Having completed its southern survey, TESS has now turned around to observe the northern sky, using the exact same strategy. As it sweeps the north, scientists continue to sift through roughly 20 terabytes of data from the southern hemisphere. Ultimately, thousands of distant worlds will owe their place on our maps to the relentless gaze of TESS. By the conclusion of its second extended mission in September 2025, TESS had scattered nearly 6,000 colored dots across the night sky, representing a staggering catalog of confirmed exoplanets and candidates. The sheer diversity of these worlds has revolutionized our understanding of planetary formation. TESS's discoveries range from massive gas giants larger than Jupiter and Saturn to mysterious sub-Neptune worlds and, crucially, Earth-sized planets. Consider HD 21749c, the mission's very first confirmed Earth-sized discovery. Though it orbits too close to its sun to harbor life, it proved that TESS had the precision to find rocky, small worlds. Then came the crown jewel of the primary mission, TOI 700d. Located in its star's habitable zone, this planet is just slightly larger than Earth and likely rocky. Using a combination of TESS and Spitzer data, scientists have even modeled its potential weather systems and atmosphere, marking it as a prime target for future study. But this system held another surprise, a second Earth-sized world called TOI 700e. Also likely rocky, Planet E orbits closer to the star within the optimistic habitable zone, where liquid water could exist. Meanwhile, Planet D resides in the conservative zone, a safer region, more likely to maintain an Earth-like atmosphere. Together, these sister worlds offer a rare masterclass in planetary habitability. TESS also revealed worlds that sound like science fiction. 1,300 light-years away, in the constellation Pictor, lies TOI 1338b, the mission's first planet to orbit 2 stars simultaneously. Nearly 7 times larger than Earth, this Neptune to Saturn-sized world navigates a complex gravitational dance. Its host stars form an eclipsing binary. One is slightly larger than our Sun, while the other is a dim dwarf. Because both stars are constantly moving, the planet's transits are highly irregular, occurring every 93 to 95 days. TESS only detects the planet crossing the larger star, as the smaller companion is too faint. Despite this chaotic choreography, the orbit is stable for at least 10 million years. However, its angle to us shifts over time. Consequently, TOI 1338b's transits ceased after November 2023, temporarily hiding it from our view. This cosmic game of hide-and-seek will end when the transits resume 8 years later. Even more extreme is Kelt 9b. Roughly twice the size of Jupiter, this gas giant is locked in a hyper-fast 36-hour orbit. It is a world of absolute thermal fury, bombarded with 44,000 times more energy than Earth receives from the Sun. With a dayside temperature hotter than the surfaces of some stars, KELT 9b is one of the hottest planets known to science, so intensely scorched that its own atmosphere is literally boiling away into the vacuum of space. But thanks to observations from NASA's TESS satellite, we now know this system is even weirder. Kelt 9b's host star spins so rapidly that centrifugal force has flattened it into an oval shape. This rapid rotation causes a rare phenomenon called gravity darkening, making the star's poles significantly hotter than its middle. Complicating matters further, KELT 9b travels along an odd polar orbit, flying directly over the star's blazing poles and distorting the symmetry of its transits. This unique configuration gives Kelt 9b an unprecedented type of cosmic season. Summer occurs during the brief hours the planet passes over the star's hot poles, while winter sets in as it glides over the cooler equator. Incredibly, for every 36-hour orbit, which constitutes the planet's entire year, it experiences this seasonal cycle twice, meaning each season lasts less than 9 hours. Scientists predict these violent temperature shifts unleash catastrophic winds, proving that the universe creates arrangements far more bizarre than anything we ever imagined. While TESS was built to be a planet hunter, its long-term continuous monitoring has made it an accidental witness to some of the most violent and cataclysmic events in the universe. Even before its official science operations began, TESS captured the graceful motion of Comet C 2018-N1 within our own solar system, alongside dozens of moving asteroids. These pristine views were captured during the satellite's crucial on-orbit instrument testing, proving its cameras were already flawless. The icy wanderer had only just been discovered on June 29th by NASA's NEO-WISE mission, yet TESS mapped its path through a striking series of clear images. This early success proved that the planet hunter would also excel at tracking fast-moving cosmic objects close to home. Soon after, it looked outward to discover exocomets, 3 icy bodies with detectable tails orbiting the star Beta Pictoris, 63 light-years away. This marked the first time such objects were identified in visible light outside our solar system. But TESS's gaze extends billions of light-years deep. In its very first months, it caught the early brilliant flashes of 6 supernovae. Tracking these Type A supernovae allows astronomers to use them as standard candles to measure the expansion rate of the universe and decode its ultimate fate. Perhaps most remarkable of all, TESS watched in real time as a supermassive black hole in a distant galaxy shredded and consumed a sun-like star, a cataclysmic event known as a tidal disruption flare. From local comets to exploding stars, TESS has underscored its immense value to the broader field of astrophysics. Today, TESS continues its quest, scanning the ecliptic plane and revisiting sectors to build an ever more complete view of the cosmos. Every discovery it makes contributes directly to the field of astrobiology, the interdisciplinary study of the conditions that could harbor life beyond Earth and what forms that life might take. TESS has laid the groundwork. It has identified the targets. Now, the next generation of space observatories, led by the revolutionary James Webb Space Telescope, are following up on TESS's catalog, piercing through the atmospheres of these nearby worlds to search for biosignatures. What began as a 2-year survey has transformed into a foundational pillar of modern astronomy. Thousands of worlds owe their discovery to this remarkable mission. And as we stand on the precipice of answering whether life exists elsewhere, we do so guided by the map drawn by NASA's ultimate planet hunter, TESS.